Problem 2 says a mortgage loan is made for $80,000 at 6% interest for 25 years with monthly payments. We want to calculate A, the monthly payments, the interest and principal during the first month, the total principal and interest paid over 25 years, the outstanding loan balance if the loan is paid off after year 10, which is the balloon payment, the total monthly interest and principal payments through year 10, and then what would be the breakdown of interest and principal during the 50th month. So once again, we have a loan. We want to find the fully amortizing payment, which will pay the loan down to 0 on the very last payment. In this case, it's a 25-year loan. We multiply that by 12, so we get 300 months, 6% interest rate, but we again divide that by 12, so we have the monthly rate. Our present value is our loan amount, and our future value is 0 because that's what we want the value of the loan to be after the last payment. So let's punch that in the calculator. So again, we'll have 25 years, and we'll hit the G key to multiply that by 12 when we enter it into N for the amortization. We get 300 months. We've got 6%, and we'll use the G key again to divide that by 12 when we enter as our interest rate. 6 divided by 12 is half a point per month. We have an $80,000 loan, so 80,000 is our present value. 0 is our future value, and then we solve for payment. So $515.44 is our fully amortizing payment. Part B asks us what will be the interest and principal portion of this payment in month 1. Now, the easiest way to understand the interest portion is whatever your interest rate is, in this case, 0.5% per month, times the balance. As we know, when a principal and interest mortgage payment is made, the interest is paid first. So we've calculated that an $80,000 balance with a 0.5% of interest due that month is $400. So if $400 comes out of the $515.44, what's left over, in this case, $115.44, goes to principal. Part C asks us what's the total principal and interest that was paid over the life of the loan for the entire 25 years. And that's pretty easy. Your payments are made up of principal and interest. So in this case, we have 300 payments times $515.44. So just punch that into the calculator. And in this case, we already have the payment up, so I'm just going to hit that enter, 300, and multiply. So the answer is $154,632.34. That's the total payments for the life of the loan. Part D asks us what will be the outstanding balance if the loan is paid off after year 10? Or in other words, what would be the balloon payment? And as we know, the payment, the $515.44, is the fully amortizing payment as if the loan would be paid down to 0. And this line on our curve is our future value. So the fully amortizing payment says that the future value is 0 when N equals. So finding the balance at any point along the life of a loan is really easy. It's just a two-step process. The first thing you do is you calculate the fully amortizing payment. We've done that already. And that says that the future value is going to be 0 when N equals 360. And that's at a payment of $515.44. But we can find the future value at any point along that line once we've established the curve. And the curve is the fully amortizing payment at that interest rate. So now that we have the fully amortizing payment in there, we can find the future value anywhere along the way. And in this case, we want to know what's the future value when N equals 120 months. So let's walk through both of those steps, and I'll go all the way through. So I'll go through both of those steps this time. But if you already had the fully amortizing payment in there, then you could just substitute the variables. So once we've established the curve with our fully amortizing payment in step 1, then we just change our N to whatever point along that curve that we want to find, and then solve for future value. So in this case, we already have the fully amortizing payment. We've set the curve to 0. Then we're going to go back, leaving that formula, that curve in our calculator. We're just going to change our N to 120 and then see what the future value is at that point on the curve. We already know the future value at 360 is 0. So now we're just going back to 120 and finding out what it is there. Since it's already in my calculator, all I have to do now is just go 120N, or I could have used the G key and just put in 10 years and then solve for future value. And in this case, we get 61,081.58. Part E asks us what's the total principal and interest that's been paid after 10 years. And once again, that's just the total payment, the principal and interest payment, times 120. So in that case, we would say, I'm going to recall my payment. That's the easiest way because it's already in there. And I'm going to hit enter and multiply it by 120 months. So enter 120, multiply, and we get 61,852.90. So just 120 months, 515.44 a month, and we get 61,852. Part F asks us, what would be the split between principal and interest in month 50? Once again, we need to know what the balance is at month 50. So in this case, we are going to solve for n equals 50. So remember, to find the balance at any point on the curve, it's a two-step process. First, we put in the fully amortizing payment to set the curve. Then we change n to the point on the curve that we want to know the future value. So in this case, it's at month 50. In this case, I already have this still in my calculator, so I'm going to recall. So I have 120 months. So it's already in there. You could start over, but I don't need to because the curve is still set in my calculator. So I'm going to hit 50n and solve for future value. And that tells me at that point we get 73,460. So that's the balance at month 50. So in order to figure out how much interest is going to be paid on that, we just take the balance times 0.5%, and we get 367.30. Now that's not the only way that you can solve this problem. There's multiple ways to approach it. Another way that you could approach it would be to calculate the difference in the balance at month 50 versus month 51, and then that would give you the amount of principal that has been paid down, and then you would know that the rest of the payment went towards interest. But in this case, I think it's pretty straightforward. Calculating the future value any point along the curve, and then in that case, we want to know how much interest is due on the next payment. We have the balance, we multiply it by the interest rate, the monthly interest rate, and then we get 367.30.